All right. So the next topic in Chapter 11 that we're going to look at is, well, there's various topics in this section, but we're going to look at each one separately. So we're going to look at the Pythagorean theorem, the distance formula between 2 points, and the equation of a circle. You know, these things show up a lot in algebra courses, so it's important to understand, or at least, you know, see the concepts of these three things. So that's why we're covering it in this course. So the first thing we're going to look at is Pythagorean's theorem. So, you know, if you don't know this already, obviously this is a triangle, but more specifically it's a right triangle, because these two legs of this right triangle form together at a 90-degree angle. That's what this symbol indicates. The slanted side is called the hypotenuse. So this right here is the hypotenuse. And these two sides are legs. So, provided you have that, then the Pythagorean theorem states the following: that if A and B are lengths of the legs of the right triangle, and C is the length of the hypotenuse, so the way I have this set up, the legs are A and B, and the hypotenuse is C. And the way that's set up, this is what Pythagorean's theorem states: A squared plus B squared equals C squared. Now, you can interchange A and B. Like, this could be B, this could be A, it doesn't matter. But C is always the hypotenuse. The hypotenuse is always the slanted side of a right triangle. The legs could be interchanged, so A and B could be swapped, but C cannot be swapped with either A or B. So, yeah, Pythagorean's theorem has a lot of applications in mathematics. It shows up in a lot of places. So it's very important to understand how to use it, especially if you go to a higher math course. You see it in calculus quite often. So let's look at the following. So, you know, in this example, I give you the slanted side of the right triangle, and I give you the measures of one of the legs, and I ask you to find the other side of the right triangle. So, you know, Pythagorean's theorem is useful to find either one of the three missing sides. Either the hypotenuse or one of the legs could be given, or any combination. You know, just any combination of two could be given, and you have to find the third side. So, if that's the case, then you'll have to solve for the proper variable, A, B, or C. And we already know how to do that because we could just use the square root property, which we looked at in the first chapter of 7, or the first section of chapter 7. Okay, so, well, let's reorient this triangle. Let's make it look a little bit better. Let me use my handy dandy gift card. By putting this triangle in a better, you know, orientation, we could look at the sides more clearly. So, you know, if I just orient this way, right? So 10 is the hypotenuse, and one of the legs is the vertical leg is 5. So, according to this image, and according to how I have it set it up here, we'll just make 5 letter B. We'll make the horizontal leg A, and the hypotenuse is always C. So by this setup, now, you know, keep in mind, A and B could be interchanged, but the hypotenuse is always C. So by this setup, we need to find side A. So in the Pythagorean theorem, a squared plus b squared equals c squared. I just got to solve that for a. So how do I do that? Well, I'll subtract b squared from both sides. They'll cancel. So I'll have a squared equals c squared minus b squared. And now, let me bring this up here. I'm trying to get a, and I have a squared. So how do I get rid of the 2? Well, again, I mentioned this momentarily, like just a minute ago. To get rid of the square, we take the square root property. That's the inverse operation to get rid of that. So to get rid of the square, we just take the square root of both sides. Now, when you take the square root of the square, they cancel each other out, and you're left with the base, a. And that equals the square root of c squared minus b squared. Now, I want you to be careful here. I want you to be very careful here. This cannot be broken up. And this is what we need. Let me say this. I mentioned this actually when we looked at square roots in the first section of chapter 7. You cannot break this up. And then you could say, oh yeah, well then this cancels out and you have c minus b, right? And that one cancels out, right? No, you cannot do this. This is no good. You cannot do this. Everything in there is no good. If you have a subtraction or an addition sign between two terms underneath a radical symbol, you cannot break it up. You cannot break up You cannot break up sums and differences of square roots. You cannot break that up. So even if this were a plus, you still can't do this. The only time you could do that is if you have a multiplication or division under here, which is what we looked at in the first section of chapter 7. We looked at the square root property and simplifying radical expressions. Okay, so now this is what I have solved. Let's get back to this problem. Now I could just solve for a very easily by plugging in the values for b and c. So a equals the square root. What is c? It's 10. And that's going to be squared minus what is b? That's 5, and that's also squared. So now just start from the inside and work your way out. 10 squared is 100. Minus 5 squared is 25. What's 100 minus 25? That's 75. What's the square root of 75? Well, you could, use your calculator to approximate this value, but remember, you want to simplify this by factoring out a perfect square. Well, I could think of a perfect square that goes into 75, and that's 25, right? Remember we did this? How many times does 25 go into 75? 3 times. And the square root of 25 is 5. And the square root of 3 can't go any further, so the square root of 75 becomes 5 square roots of 3. Which, if you do that in your calculator, 5 times, excuse me, 5 times the square root of 3, enter, gives you approximately 8.66. So that's what side A is equal to roughly 8.66 units, or more specifically 5√3 units. Okay. So again, that's Pythagorean's theorem. All you really have to understand in this course is to apply Pythagoras to find one of the missing sides of a right triangle. But you do see this often in trigonometry, college algebra, and you'll see it in calculus, especially from a trigonometric perspective. Okay, so let's go on to the next topic, which is the distance formula. Now, if you have, if you have a graph of a line between two ordered pairs, you can find the distance between the two ordered pairs. So, and actually, this formula comes from Pythagorean's theorem. I'm not going to derive it, but it's pretty cool. I usually do the derivation in college algebra in MAT160, but yeah, this right here is the distance formula, and it just measures, everything's underneath that square root, by the way, and it just measures the distance between two ordered pairs. So do not confuse this with the slope formula. I see that's a big mistake. This is the distance between 2 points. This is not the formula for slope between 2 points. That's different. That's completely different. That's one big mistake I see students do with this distance formula and the slope formula. They confuse the two. Like as soon as I ask a question like this, I immediately see students use the slope formula. But this is the distance formula, not the slope formula. Alright, so if this is my first order pair and this is my second order pair, then this is x1 comma y1 and x2 comma y2. So now you just plug it in and simplify from the inside, work your way out. So I have the quantity x2, which is 3, minus x of 1, which is negative 2. So I'm going to have minus negative 2. So I'm going to have a double negative showing up. Because I have a minus from the formula, which is right here, and then I have a negative from the negative 2, which is the x1 coordinate. So I'm going to have negative 2 there, and that whole quantity is squared from the formula, plus y2, which is negative 1, minus y1, which is 5. And that whole quantity is squared. So now you just got to simplify from the inside out. So 3 minus negative 2 is 3 plus 2, and that whole quantity is squared, plus negative 1 minus 5, quantity squared. Okay. I'm just doing this step by step, just to show you all the work. 3 plus 2 is 5, and that whole thing was squared, plus negative 1 minus 5 is negative 6, and that whole quantity is squared. So now you can actually square these. So 5 squared is 25, plus negative 6 squared is 36. Now be careful about that. This whole thing is squared, the 6 and the negative. So if you type that in your calculator, right, negative 6 quantity squared, that's positive 36. But if I did not include those parentheses and I just wrote that, you're going to get negative 36. Because in this one, the negative isn't being squared, it's just sitting out front, so it just goes along for the ride. Alright, so 25 plus 36 is 61. So you have the square root of 61. Now, can I factor a perfect square out of that? Well, let's see. 64 doesn't go in, or 61 doesn't go into 4. 61 doesn't go into 9. It doesn't go into 16. Nor does it go into 25. Not looking good. So the square root of 61 doesn't simplify. You can't factor a perfect square out of this. So that's it. And if you want to approximate that, the square root of 61 is 61. That's roughly 7.81 units. So that's the distance between these two ordered pairs. That's the distance, not the slope. Remember, we're finding the distance. Don't confuse one for the other. So, you know, visually, if I wanted to illustrate this visually, here's a coordinate system, a really rough coordinate system. There's the x-axis, there's the y-axis. So if you want to find the distance, let's say this is a random graph right here. All right, if you want to find the distance between that ordered pair and that ordered pair, what you're doing is you're finding this measure right here. That measure right there is the distance. And I'm not going to go through the derivation, but yeah, this shaded part of the line right there, that's the distance of between those two ordered pairs. And for this particular example, that distance is this value. Not much to it. Not much to it. All right. So the last thing we're going to look at is the equation of a circle. Now, this shows up a lot in algebra as well, especially in trigonometry. And actually, there are alternate forms of the equation of a circle, but we're not going to talk about that in this course. That's a more higher level topic. So you need two things. You need two pieces of information to find the equation of a circle. You need the ordered pair of the center. So you need the center point. We denote that as the ordered pair HK. And you need the radius, which is the distance from the center of the circle to the edge of the circle. And if I have that, then I can find the equation of a circle. And this equation in this form actually has a name. It's called the standard form. It's called the standard form for an equation of a circle. There's also another form. We don't look at it in this form or in this course, but there are various forms of the equation of a circle. So all you really do is, if you have this information and this information, you could find this equation rather easily. Just plug in those points and the radius value and simplify it. That's it. So in this example, all right, let me label my axes. So find the equation of a circle with this center point. So here's the center point, 2, -5, and radius square root of 13. Now, if I want to graph it, okay, well, first of all, if I want to graph it, I should approximate what the square root of 13 is, just to get an idea. So square root of 13 is roughly 3.6 units. So when I graph my center point, 2 comma negative 5. So here's 2, I go down 5. So 2 comma negative 5 is roughly right there. Now, if I want to get the edge of the circle, I just got to go out 3.6 units in every direction. So I'm going to approximate that as best as I can. It's roughly 4 units. So I'll go out 1, 2, 3, 4. So roughly right around there is another edge of the circle. 1, 2, 3, 4. So maybe right there. 1, 2, 3, 4. So roughly there. And 1, 2, 3, 4. So roughly right there. So I'm just, picking points, per se, that are on the perimeter of the circle. It would be much better if you had a protractor, but more or less that is the equation of the circle. Well, that's the graph of the circle. All right, I just put these points here for the sake of getting a rough idea of my perimeter, but this circle is graphed here. Now if I want to find the equation, I just got to use the standard form. I just got to find the radius and the center point. Point them in here for h, k, and r respectively and simplify it. Nothing to it. So the standard form is x minus h squared plus y minus k squared equals r squared. Now just plug in this information. So the center point is h comma k, and the radius is the square root of 13. So I have x minus h. What is h? 2. Quantity squared. Plus y minus, what is k? Negative 5. So I'm going to have minus negative 5. I have a double negative there as well. And that quantity is squared. And that equals the radius squared. Well, my radius is the square root of 13. And that is going to be squared. So now when I simplify this, so the first expression, x minus 2 quantity squared, is fine. Now I have a y minus negative 5. That becomes what? Minus a negative is a positive, so that's y plus 5 quantity squared. And that equals, what's the square root of 13 squared? What happens to those things? They cancel out. Right? This is root 13. Root 13 and the square, they cancel each other out. I'm just left with 13. This right here is the equation of a circle in standard form. That circle. That's it. Nothing to it. Just make an observation here. If you have a plus sign here, that means usually the coordinate is negative. Because in the standard form, the minus signs show up in the formula. So if you have a plus sign here, it means that coordinate is negative. Because you have a minus a negative there, which is positive. But yeah, I mean, that is really it for this section. Just, some very basic topics that you'll see in higher level algebra courses and trigonometry and calculus and stuff like that. So it's important to understand to see how they work. But yeah. So yeah, those are the only 2 sections you were looking at in Chapter 11, which was the 11.1 and this one. Yeah, so that's the end of this video.